Well, hi, welcome to my shop this morning. I'm going to go to the next step with the radio. Apparently I'm going to have some help from my cat here. So, and mostly that's because it's rainy outside, so the poor cat has to stay in. Last video I tested all the tubes on here. Two of them came out quite weak and are targets for replacement. One is the 6Q7, I think that's this one here. Supposed to test between 500 and 800, came up at 300. And the 6A8. 6A8, I don't know which ones it is offhand, but anyway, the 6A8 tested 720 on the triode. I did not say that. So this is a two-part tube. Part is used for amplification, other part's used for driving an oscillator. The oscillator side of this tested well below where it should test. So I have, lucky enough, in my own stock of tubes, I have two brand new. Well, new old stock 6Q7 and 6A8. 6Q7. Right. So, and you can see that the older tubes are these glass ones. And many of them required a metal shield placed on top of them. These were modernized into this kind of tube. Let's pull one out here. So this is probably the first time this tube has been out of its box since the day it was slid in. Isn't that exciting? Not really. Come on over there. Challenges at every turn, out the bottom. Very seldom have I unwrapped a brand new tube like that. There we are, Ken Rad, made in the USA. Has a guarantee on it. This radio tube has passed rigid tests before leaving the factory and is guaranteed to be free from mechanical and electrical defects. Should it fail to give satisfactory service, return it to the place of purchase with full details of your experience. Okay, go argue with the guy you bought it from. That's what that says. License notice. The sale of this tube conveys no license, either expressed or implied, under any patent, blah blah blah. There's a big long patent list here. Wow. Push tube downward to test. Oh yeah, so this box has no bottom, and when the tube is in it, it's sitting like this. So you can take the tube in the box, put it into your tube tester, open it up, push it down so the prongs come out into your tube tester, and test it while it's still in the box. Huh. How do you like that? So we don't have to test this one. It's guaranteed by Ken Rad. Just put this back here. (6Q7). And now this one, Sylvania. Let's see what they say about their tubes. Oh, there's no inner protector. Oh yeah, it's in there. They don't say much. Sylvania, made in USA. Okay, so I got two pretty good tubes. This one has a touch of rust on it. Okay. Yeah, that's not a problem. Okay, so but there is an issue with using this kind of tube, and we're gonna check that out before I stick them in. This issue has to be dealt with, so to speak, and the issue is this metal can is connected to the chassis just by contact here. So there's going to be no metal can put over top of this tube because it has its own metal can. Inside it is a glass airtight tube like any. Maybe not like any, but anyway, inside here is the airtight part is the glass part. So this metal tube has to be connected, this metal shield has to be connected to the chassis, and they do that through pin number 1. So this is pin number 1, so that's just connected to the metal can here. This tube, pin number 1 is not used. So that means there's a socket terminal underneath the radio, underneath the socket, that's not being used. Radio designers know that, and they'll use that spare pin to make contacts, to make connections. It looks like it's hooked up to the tube. It is not. But if you put this guy in, whatever it is that's hooked up to pin 1 is now hooked up to the metal can on the tube. This may be the case with this. I took a quick look at this tube, and it appeared to be the case that this tube was put in without pin 1 being considered. Don't know that that's true, and today that's what I want to sort out. Okay, so let's go around, we'll look at the back, we'll look at pin 1 on this tube here. Pin 1 on this tube here. Pin 1, so it certainly appears to be grounded on this tube. Yeah, it's pretty clear. It's pretty clear it's grounded. Let's just double check. Some people occasionally ask me where these holders came from. My unstable meter holders or stands or whatever you want to call them. Nothing special about those. These things are really intended for holding your TV remote or maybe a cell phone or something of that sort. So I think they're not hard to find, but that's what you would look for. Don't go looking for a meter holder. There's no such thing. Okay. Now, one here. So we'd be curious about pin 1 on the 6Q7. And just bear with me one moment here while I make sure I know which one for sure is the 6Q7. 6Q7 is this tube here. So pin 1. So the way we find pin 1 when looking underneath, we find a little key, and the first clockwise pin is pin 1. That's pin 1, 2, 3, 4, 5. That's how you count them. But looking under here, I can see where the key is. And there's pin 1. It certainly appears to be grounded. Yeah, I was going to check these. That's what I was doing. Got distracted. Let's go back and check this one over here. Pin 1. Grounded. And up here, pin 1. Grounded. And then the last one is the 6Q7, 6A8. Okay, so the 6A, the 6A8 is located in a difficult place to observe the bottom. The 6A8 is right up here. In the new one here. Let's test the pin right through here, see if it's grounded. So now looking down, you count the other way. That's, oh my gosh. Oh, it's okay, it's okay. Okay, that oh my gosh was me thinking I wasn't. Anyway, not to worry. The oh my gosh was nothing important. So this is pin 1, and there we see, can you see the meter? Grounded. Who's working at the door here? Okay, so that's great. So it turns out the pin 1s are grounded, and all these tubes can simply be put in, these new tubes, which I will now do. Okay, and then the last one, once again, just to be absolutely sure, 6Q7. This unshielded one here. Okay. Now this has come off. I've taken this off once, so probably get it off easy now. Famous last words. There we go. Tube out. Double check. This is the one with the loose base too. 6Q7 written right on it. 6Q7 written right on it. There we go. That's right. This tube did seem to have a shield on it at one time. I made that observation before, but not now. Well, now, yes. So the shield can have a couple of different effects, but the main one is blocking accidental signals from getting into the tube or getting out of the tube. That's the main idea. Can't get across a grounded piece of metal. I guess that's the way to put it. Okay, so with these two tubes in, and this guy hooked up properly too, should be able to operate this radio. Now, excuse me. I wonder if it's time to plug it right through its amplifier and everything at this point. Because I still have the alignment to do. And I don't think I want to spend time aligning it with all that other, all those, the amplifier tubes rolling, running, and everything. Excuse me. So, I think I'm going to revert back to the way I was operating it before. We'll just keep the supply voltage low, a little low on it, so it's running on maybe 100 volts or so. Run through the alignment procedure. First time through is kind of an educational thing for me, and a rough alignment, if you like. And in the course of doing that, we may discover that there's other problems with the radio, which is why we're doing it at this point. One of the things you want to align on a radio is the front dial. And of course, that's completely hopeless on this radio right now. I think it's hopeless. Well, maybe it's not hopeless. I'm going to have to straighten out this bend. It certainly has lots of dial markings on here. They're all correct. The pointer here is just free turning. Not really sure what that's all about. And we have this white one which is running around and around and around. I'm not quite sure what that's all about either. And I have a good guess at it. Can we align this? We can certainly do the IF alignment. Now that introduces an interesting question in itself. And that's what's going on with this can here, which is not original. Why don't we study that up on a schematic and just take a look and be sure we know what this can is doing. So the way this radio is working is the signal is coming in from the antenna, it's being amplified by this tube, it's then going into this tube, which is the mixer tube, coming out at the IF frequency, and then running through the IF. We could guess it's going this way through the IF and onward. That's a really good guess. We have a tube, we have an IF in between this tube, an IF in between this tube, and then this. So it looks like literally looks like there's 3 IFs in a row. That's what it looks like. I'm not sure what else it can be. Well, let's go find out what else it can be. So, hey, first of all, let's just start here. So in this diagram, right away, look at first, second, third. Look at the size of the can. So there is no question that the IF transformer here has been changed out. And this might match up with the cooked up resistor underneath and all that kind of stuff. So we can kind of see the whole signal flow here. From the antenna through the first tuned circuit, RF amplified, sent to an oscillator where it's mixed and comes out at the IF frequency, which is what, 456? I don't know. It's written up above anyway. 456 or something like that. At that frequency, it's then sent through this transformer, amplified, this transformer, amplified, this transformer, and now it's out to the detector. There's very, very powerful amplification in this radio. This front end here is, well, in most radios, or many radios, this is 2 tubes, this whole thing here. Okay, yeah, two tubes, maybe three tubes. Three tubes. You have a mixer, IF, and a detector. Three tubes in most radios. Ooh wee. So the way this would be tuned up is you feed a signal into this grid. This tube will amplify your test signal and feed it through this transformer. I can pick up the output of this transformer at the top of this tube, or better yet, at the output of this tube. It's a better place to pick it up. Or I can connect my meter to the AVC line, which is even easier, and just watch the ADC voltage. The ADC voltage is developed by this tube right here, and it's based on how strong the signal is that's coming through. The stronger the signal, higher the AVC voltage, automatic volume control voltage. That's the best way to do this, I think. So and I've used that voltage once here already, I think, have I? I'm not sure. We'll set up that way. We'll run the radio, and we'll perform the alignment through the IF. I'll feed in I could feed into here the IF frequency. As long as the radio is not picking up any signals, it shouldn't be producing any antenna signal IF stuff. Or I can even pull this tube right out. That'll certainly shut off any other signals coming into this tube. So all that's left is my signal, my 456 or whatever it is. That's great. In fact, I can really, because this is almost certainly relatively well tuned, and the alignment instructions are written on the basis that the radio has never been aligned, it's completely out of alignment. You can't really, you have to go stage by stage in that condition. But here, since the whole thing's really pretty much lined up now, I mean, we've heard it work, I should be able to feed the IF in here, listen to it on the output here, or not listen to it, but watch it on the ABC meter, and do all these cans at once. And we'll see what we got. Now, what is the proper frequency here? The proper IF frequency be up here. Does it say it anywhere? It's got to say it somewhere. I'm pretty sure I saw it. Said somewhere. Could be written in a note. Could be you've already seen it and you're wondering why I haven't. Oh my gosh. They hidden. Oh, there it is there. Written. Okay. Intermittent free 456. So that's what we're going to tune the IF to. 456. Okay. So to set up the radio for this test, I'm going to pull out the, I'm going to do it without these tubes. Pull this out. I could leave these in. All they would do is put heater load onto the big transformer. We don't need that. That's not helpful at all. Having them out, of course, will allow the B plus to go high. Can compensate for that to some degree by reducing the actual supply voltage to the radio. But that, in fact, also reduces all the heater temperatures in the tubes. So can't go too far with monkeying around. We'll also get a chance to test the Magic Eye tube and see that it actually reacts. So I think probably the best thing to do is to pull out this first tube so it's not there. You know what? No, we're not. Jim, the first test is make sure the radio still works. That's the first thing. So leave it all together. Connect the output. It's still connected here. The audio output. The volume control. Am I forgetting anything? Well, we'll know soon enough. So audio, I think the audio is all set. You should be able to hear it. Let me just test it. Put on my own headphones here so I can hear what you're hearing. So that hum, let's just see, and this. So hear those two hums? Here, watch. I have a hummy sound system here. So those hums are inherent in my hookup here. In fact, let's do this. Put this up. It's still humming, see? So I don't know exactly what's causing the hum, but it's not the radio here, so let's not be surprised. Now I have this turned way up. Normally we're listening about here. You don't even hear the hum. Yeah. And then we have the volume control up here, which needs to be turned. So, and I disconnected the antenna. Let's reconnect it. I think we're ready. Why not pop the eye tube in right now? No. Okay, I think we're set to go. That's one of the few times I remember to plug it in. We should look at the B plus voltage. We should really be monitoring it. So let's do that. B plus voltage. Keep an eye on it right here. Okay, so this reflects the voltage of the power supply, but not the voltages reaching the tubes, which are somewhat less. And okay, so we're expecting something like 350 to come up on here. Would really prefer it to be around 300. I think 350 is what we're going to see. Two lights in. Okay, I think we're ready now. Yeah. Dim lights. There they go. Perfecto. That's Italian. Now, give it a minute. I don't have the volumes up anywhere yet. Okay, turn up the volume onto the sound system you're listening to. That's that hum that we know comes from my sound system. I didn't hear a thing. Let's turn it up here. Maybe we gotta...
So we started doing it now. We can get better as a team, and each and every year when I was playing, we definitely had the resources to go out and do things to make our hockey club better, and they did them, and they wanted to win. This is a franchise that wants to win championships, and they're going to do the best they can to try to make that happen.
All right, the hard question comes: yes or no? The Leafs have a captain opening up.
I'm going to sit on the fence. I don't know. I'm one of those fence sitters when it comes to this, because, you know, if somebody's going to be the captain and they're ready for it, of course they're going to be a captain. And I think there's guys in that locker room that are absolutely ready and ready to take it.
But
we'll have to wait and see what happens. There's so many guys that could be captain. And be a great leader for this team as a captain.
No change whatsoever.
At the end of the day, it's up to the management and the coach's decision to make that happen, and if they don't feel comfortable in doing it, then that's their decision.
Did you ever play a year without one in the NHL?
Oh, God.
Well, it hangs on for quite a while, doesn't it? Now that's interesting in itself, because that kind of tells you that the B plus can stay up without the supply running while it bleeds itself through the tubes for quite a while. And that's a very good sign for the power supply capacitors, which of course were replaced 20 years ago. It shouldn't be surprising that they work well. I'm going to take this off the B plus now, so we don't have a dangerous connection like that. So AVC, actually I want to move this meter now to measure AVC. We're going to use this one. No, we're not. I'm not going to use a digital meter for that. To measure a fluctuating voltage, when you're going to make adjustments and it's going to change a little bit, using a digital meter is actually not very friendly to the process. So we're going to use this VTVM here. Really shouldn't make that hum when I do that. I'm hesitant because I think the hum is telling me that I've got a grounding situation in my shop here. That's not what I think it is. Not sure how that could be. All the frames and boxes and cabinets of all my equipment are all connected to this. Can you see a green wire down here? It's hard to see. There's a green wire down here, and they're all connected to it. I did this 6 months ago or so, so that there can be no what to call it, capacitive voltage riding on any of these pieces of equipment to generate hums like the sort you just heard. Which okay, I'm not just. Let me just check that a little bit, just to see, just to be sure. Why would we have a hum between here and here? Now we need to see this. So what I'm looking for is just a unexpected voltage. So when I connect the sound from the radio through the mixer boxes and whatnot, I'm actually connecting it, I'm grounding it right through to my computer and everything. Like basically my shop is in two pieces. I have the shop with all this stuff and equipment, and then I have my computer, which is actually a little bit separate. Not much though, but surely when I hook up this audio connection, I'm connecting the two systems together. I think that's probably generating a ground loop of some sort. I don't know. So let's see what we can get here. I'll just touch the ground here. Yeah, that's nothing. What about over here? A little tricky to find something grounded to touch here. Same. It should be the same. Should just be the same. So you know what? That could be the voltage right there. That point 0.25. So if you look over, you see there's a 3-prong plug on this the receiver, and I've checked already. The green wire is connected solidly to the chassis. So I say, wait a minute now. If this is plugged in here and with the ground prong, and all my equipment is also tied essentially to the ground prong, how can I find any voltage between anything? And part of the answer is this, that this actually isn't grounded. Can you see the prong here is not plugged in anything. This is just a 2-wire extension cord, and it doesn't lead back to an outlet, it leads back to a transformer. So I'm going to guess this arrangement, with this not grounded. So why don't I ground this? Why don't I put a ground on this? Why would I hesitate to do that? And stop relying on this. I am putting a ground on when I do this. Okay, I don't know how to get around the hum. That's the bottom line here with using this meter. I don't know how to do it. What if we just try a different meter briefly here? I'm going to have to investigate this. Maybe tonight I'll come in and see what I can investigate. Hum 2. So that's just a ground wire from another meter. It should sound exactly the same. They sounded different. Okay, so now I have a long history of having weird things happen with this meter. Okay, so we're gonna not use this meter. We're gonna use this other meter. Let me just get on here if I can. You know what? I'm gonna stop and sort this out here. Let me sort this out once and for all. So in looking, oh, by the way, perhaps the sounds a little different now. I found there were some more problems with my microphones in here. So if things sound a little better or a little different, that's what's happened. I've simply fixed my problems with microphones. Okay, now, and discovered one of them hums. Is it humming? Or is it hearing a hum? I don't know. So I'm going to leave it down so you don't hear it. So I just have my bench top going. Now, one of the places the ADC voltage is applied is right to the magic eye. It's the ADC voltage that makes the magic eye operate. So the magic eye is really monitoring the ADC voltage. So now we don't have the magic eye plugged in, but what I've done here is I've simply used the socket, picked the pin, I'm pretty sure, which is the grid for the magic eye tube, which will have the ADC voltage on it. So it's just an easy place to get it. And I'm stuck in this terminal, but I'm not absolutely sure I've counted this right. I'm not sure. So I want to be sure. So I'm going to operate the radio, play a station, should be a ADC voltage measurable, should be negative relative to the chassis, and test this wire. I'll use this meter here for the testing part of it. And we'll eventually use this meter over here, which is reacting to the fact that it's... We probably won't use this meter over here because it gives me so many headaches. Yeah, I'll bring down a different meter. Too bad for you. I really love to use that meter. Every time I try, it doesn't work out. So I won't try this time. Okay, so let's find out if this is ADC or not. I think I'm all set here. Power on. Volume so we can hear it.
Treatment things the Maple Leafs are willing.
I heard that Toronto was, willing to go to 11 million, but it's a 7-year deal. If
Okay,
they want to
so
do that.
is this the
At this
ADC
point in
voltage
time,
here?
I think
No, we don't have to listen.
that
We know what's on it. So I'm looking for negative voltage. That's the first thing. And we get a whole lot of nothing. I got this connected right. So the lead is grounded. Try again. Nobody home. And I pulled this out. My first guess was bad. So maybe this is 3. So that's probably B plus there. We just saw it go off scale. Off scale at 200 volts. So this is the B plus coming up here. 330. There's a minus. So we got one minus here. Minus 1,000. So minus looks like minus 3 volts. Where? Here? Yeah, that's it. That's the guy. We're going to put this guy in here. Check again to make sure I haven't got B plus on the end of this wire. Oops. Here we are. Now tune the radio, and this should vary, and that's the proof. Here we go. There it goes. See it vary up and down? So that's the proof. I've got the ADC voltage. I've got what I need to perform the test here. We just need a better meter over there. Now it's going to take me 2 seconds to set this up. This is a very, very reliable meter. Never lets me down on this one. Volt to start. Now I'll have to probably switch the leads because it's going to want to go the wrong way, I think, here. Let's give it a moment. Okay, I don't have the leads connected, so we'll connect them up. Looks good. This meter is reading from 1 volt to 10, so it's reading reading very, very low here, so it's not too good. So my little connector here is not doing so well. This is where you accidentally pull it out and stick it into the B+, and the world changes shortly after that. Let's just go back to testing, make sure. Minus 1.7. I just don't think that's making a contact. How can it not make a contact? It must be making a contact. What's with all the wonkiness? I expect this to come up and just sit in one spot. This is no good. Is it this thing? Let me stick this right in. Don't make the mistake now, Jim. So I have the signal partially tuned. You know what? I'm going to put this back in because I can't see how it cannot work. You know what? These are lousy. Let's just do this. Often these are not soldered in here. I don't know about this one. Don't make the mistake. That seems a little better. So that fluctuation in the meter is almost certainly the signal we're listening to. Let's listen to it. Tune it.
This feels like a 1970s time police drama or something. Ziggo Cops. Doesn't it? I love it. Okay, so we're going to slowly unveil this. It would be better if you do this on social
Shouldn't see this audio here.
I'm trying to figure out how to do it right now. Okay, well, I've got Twitter at Mike Zigamanis. Give me a follow. I'm glad you know.
So I think there's problems with some ADC capacitor in there or something.
Instagram's different. I think Mike Zigamanis was taken on Instagram. I think that's...
Yeah, or there's something more to this that I'm not getting. But normally this is not fluctuating with the audio signal. It should be steady. Should be steady. Wow, a little hard to do an alignment with that kind of thing. Of course, I'll be putting in a steady signal when I go to do it. And if we tune out, let's tune out here.
No trouble for not knowing how to...
Get right down below a volt here. That's 1 volt now and 0.1 volts here. Well, so a typical ADC voltages go from maybe 0 or maybe the bottom is a couple of volts up to as high as 15 volts. Depends on the kind of tubes that are being operated in that. So this ADC voltage is fluctuating only a small amount. It's only a volt or two. So that's a sign of weak IF. Okay, so the next step along the road here is to introduce the IF signal. I'm going to stop the video and just set that up here. Okay, I think we're ready to go here. So what's happening now is signal generator feeding a signal into the radio through this 6A8 tube grid at 442 kilohertz right now. You're listening to the output, the slight hum and a bit of crackly hiss is the output. Hooking up the signal generator at this point in the radio, because the output of the signal generator is low impedance, this will rob out any signals that have managed to come through the first tube from the antenna and to get to this point. So actually I have the radio all connected the way it would normally be connected. I haven't interrupted anything anywhere. And then what we're monitoring is the ADC voltage, showing up absolutely nothing right now. So the first test we want to do is find out, well, where is the IF set right now? So I'm going to tune the signal generator through the IF frequency. The IF frequency, it should be 456 kilohertz, and we'll find out where it really is, just by listening. Okay, so keep your eye on the red numbers there. So we'll try to peak the meter here. So this meter is showing the output of the detector where it rectifies the output of the IF chain, if you like. So this very much reflects what is coming out. We're on, it's a very, very low voltage here. It's not even 1 volt coming out. So if I ramp up the signal here, we should see this go up. We should be able to get this to go way up. Let's go way up. So that's 10 volts. So this is now 10 volts to 100 volts. No, 1 volt to 10 volts. Get it right. Interesting enough, well, we can't get really even up to a volt here. No, that's kind of interesting. I don't know what the ADC voltage range really should be in this radio. It's got some old tubes in it. Maybe it doesn't take much. But what we have discovered, let's just double check this again. We'll peak the meter. Okay, so by my reckoning, the peak is at 451. My frequency counter is a number or 2 low. So that's actually 449. So it's off. Now, there's 2 ways to be off with this. One is it is tuned specifically to this off frequency and everything is tuned the same. That's not so bad. Or what this is really telling me is the IF is all over the map. All these little transformers are tuned differently, and in sum they end up 451. The second one means there's a lot of potential boost. That a lot of signal is not getting through. So what we're going to do is we're going to twiddle these 6 screws just a little bit. I'm going to watch the variation on the meter here and see if it goes up. If it goes up at all, then we know it's poorly aligned. So it's just basically a test, because there's a chance the last guy aligned this perfectly and all I can do is just make it worse. That's what I want to find out. So we'll start with the first one here, just watching the meter. Did you see it jump up there briefly? I'll put it back to the top. So this was slightly off, and these are hair trigger adjustments here. We'll try this one. Down that way and up this way. Yeah, look at that. Yeah, so this radio is poorly aligned. I think that's what we could say. So it's well worth doing the alignment, no question about it. Let's do the IF alignment. Most of the increase in sensitivity is in the IF. That's where all the amplification takes place. It's really important to get this to work right. So we want to do it at 455 though, not 451. 456 actually. So I'm going to set this to where it should be. That would be 457 or so on here. You can see how the signal rolled right off. I'm now going to peak the signal up and match it to that frequency. There we go. That one's just by ear. Yeah, of course you really can't hear it, can you? Let's try that again. Watch the meter now. Now when you're doing this kind of work and using the ADC voltage, there are capacitors that delay the impact of the ADC. The result of that is if you move these things quickly, you'll be looking at the old position of the ADC voltage, if you like. So you'll see it do things like this. It'll jump up and come back. It'll do stuff like that. that comeback is the time of the ADC capacitor charging up. You gotta let that time go by. If you're doing it like using the ADC voltage as your guide. Oh, that's quite a bit. This will make a tremendous difference in the sensitivity of this radio. And for this radio, I mean, this radio has a super duper front end on it here. Middle. This is the middle actually. But it has a super duper front end too. Look at that. Gives you an idea how dull this radio was. Now this last can is not original, so really curious what's going to happen here. Oh my gosh. Now with a just turn that down a little bit. With the non-original can here, it's possible that you could tune this thing up to the point where it just oscillates. It becomes so sensitive that it feeds its own signal back and starts to oscillate in here. So I'm a little curious, especially when you see this thing jump way up. If that's the case, the last guy would have tuned this off a little bit, so it's not so likely to oscillate. That's what's going through my head while I'm doing this. You know, whether that's really a true situation. Here we go. This is the last one now. This is the last one. 10-volt scale now. Ooh, what's that? What's all that? What was that? So go right to the start and go through them again. You really should start here and work your way back. Hey, why don't we do that? We'll work our way back from here. It's really a better way to do it. Now, I mean, once you get these tuned up relatively good, I mean, a little variation there isn't going to mean much. If you notice, I'm using a metal screwdriver on this, and no doubt, I have my hand on here too, shame on me. So these are capacitors at the top, and generally a metal screwdriver doesn't cause any problems, and what it gives you is an absolutely stiff shaft here. If this shaft is plastic and it's not super duper stiff, then it will be springy. You know, you'll turn it a bit, the screw won't turn, you'll load tension into the shaft, and then when the screw turns, it jumps. With a really stiff shaft like this screwdriver, that won't happen. So there it is, tuned up to 456. I wonder how different it sounds now. Easy to find out. So I'll turn it down, as I remember where that happens. Take this off. That'll release the hounds. What do we got? So I barely upped the volume here.
Social media news, I'm your real co-worker. Anywhere else, but the Canadian government has made contact with aliens, and they are covering it up because the aliens aren't politically correct enough. No respect for the taxpayers.
Yes, today our Canadian election is starting today. Today the writ is dropped. That's the phrase that's used in Canada, which means the document that triggers the government to begin the election is prepared and made public. So we start our election today. It's 40 days long and it's over. And yeah, there's been a little electioneering going on up until this point, but not much. But from here forward, Canadians will be blasted with political stuff for 40 days. Then we vote and it's over. And we carry on. So, hello Americans, 40 days, all done. 40, that's just over a month. Start to finish, and then all done. We don't have the permanent election thing going on here. Okay, that's great. The next part of the alignment process, a little bit difficult, like I was saying, to do with the cracked glass here. And how important is it to do at this point? Not very important at this point. What we've discovered is there was a lot being lost up here in the IF, which is not being lost anymore. That's fantastic. Well, maybe the next step is to plug the amplifier in here, hook it up to the speaker, and see what this thing really does as it stands right now. And then we make some decisions from there about where to go forward based on, you know, how much hum is coming out of it, or what other problems that might appear. I think that's the name of the game. Until I get the glass plate, I'm not sure I really want to try fiddling with this and all that kind of stuff. In fact, this receiver may go away now for a week or 2 or 3 or whatever it takes to get the glass plate. But very good. Good. Thanks a lot for watching, and we will carry on.